So we're going to look at question 4 from exercise 5G. So it's all about inverse functions. Now, if y equals x, y equals the original function, y equals f neg 1, x is the inverse. Okay, so this is the equation of the original. It's linear. What do I know about this equation? Well, I know that the y-intercept's at negative 6. Is that negative 6? Or if I write it in corner form, 0, negative 6. I also know that the x-intercept is when, like a y equals 0. So we go 0 equals 2x minus 6. So x equals 2. If I move the 6 to the other side and divide both sides by 2, I get x equals 3. So 3, 0. So I'm going to draw the original function. Okay, so let's go here. Let's draw axes. Now, it's advisable to do some grid paper because you actually need to be quite accurate when drawing the inverse. Okay, because in this case, the scale actually matters. So this is why I've gone to the lengths of doing this by hand. So I'm going to draw the line y equals x just to show you what it is. So just go like that. Yeah. So I'm going to go like this. Okay, so that's my line y equals x. It goes all the way down. Okay, so that's the line y equals x. This is what we're going to reflect over. Okay, now my original line will be, I'll do it in blue. We'll have our y-intercept at negative 6, so 1, 2, 3, 4, 5, 6. Negative 6, and an x-intercept of 3, 1, 2, 3. So 3. So what you're going to do is you're going to draw a line that crosses both of them. Okay. Now this is tricky because what's going to happen is you're gonna oh, it's not very good. So you really need a ruler for this. So what's going to happen? I should curve. What's going to happen is that eventually it's going to cross that line somewhere. Okay. So if you keep going, it's gonna cross the y equals x line. Okay, if you continue. Now I'm going to draw the inverse as well. So the inverse will be when, okay, so remember inverse, so this is original. Inverse will have everything flipped. So this will be negative 6, 0, and this will be 0, 3. Okay, so 0, 3 is over here, 1, 2, 3, and negative 6, 0 would be here, 1, 2, 3, 4, 5, 6 here, and what you're going to do is draw another line. So this is your inverse line. So what you can see is they're going to intersect somewhere up here. Okay. Now, so you always label your inverses. You label that f neg 1, and you label that f. Okay. Now, I need to find the point of intersection. So B is finding the point of intersection. The theory I went through is that if you, I'll go through this again because I know the class got really confused about this. If I have a line and it looks like this, and the line y equals x looks like this, what will happen is, so this is y equals x, this is my f. What would happen is the intersection between the original line and the inverse, not the inverse, the line y equals x, the mirror. If I draw the inverse as well, what would happen is they'll all intersect at the same point. Okay, so if I draw the inverse will look like this. This will be f neg 1. What happens is the intersection between f and f neg 1 will be the same intersection between f and y equals x. Okay, so the easiest way is to find the intersection between f and y equals x because it's easier to solve by hand. Okay. Now, you can do the intersection between f and f neg 1, but that's usually harder. Okay, that's usually harder. So what you're going to do is just find the coordinates where they intersect. So the easiest way to do that for this case is f of x equals x. So you're letting your original equal, you're trying to find when it equals the mirror equation, so y equals x, so if I put x. So f of x happens to be 2x minus 6 in our case, equals x. And I rearrange, I move the x to the side, so this becomes x minus 6 equals 0, x equals 6. So now the trick is if it's on the line y equals x, remember the equation y equals x means whatever your x value is, you want the same y value. So the intersection point will be 6, 6, because your x value is 6, your y value must be also 6. So this graph intersects at 6, 6. Okay. So hopefully that gives you a rundown of how inverses work, okay? And also the domain and range of the inverse swap. In this case, it doesn't matter because for a normal line, your domain is reals and your range is real. So even if you swap it, it's still going to be the same. Hopefully that helps.